Okay, well, look, we might kick off. First of all, welcome. My name is Michael Conlon. I'm head of School of Electrical Electronic Engineering in TU Dublin. And what we're doing today is giving you a very brief presentation of the master's programs in the area of electrical and electronic engineering in TU Dublin. There are 5 programs we want to cover, and hopefully you'll get an idea of the of each of those programs as we go through it. Just a couple of general comments initially. We're across 3 campuses, Tala, Blanchardstown and City Campus, and the programs I'm presenting this evening cover those 3 areas. As we go through this, you'll see, I'll just show you the first of all the list. Where we have multiple codes there, they generally mean that it's a full-time and a part-time offering. And as I say, we have 5 programs to present today, and one of my colleagues will be presenting each of these, and we'll go through them. Just to say generally with the TU Dublin programs, usually we have 60 ECTSs in various modules associated with the program, and then there would be 30 ECTS as part of the project. And that's a common structure, maybe with some slight variations that would apply across the 5 programs. With respect to the program starting in September, we've been presenting the programs in various modes for the last while, and we will be retaining quite a degree of hybrid mode of presentation. So first of all, I'd like to hand you over to my colleague Malabika Basu, who's going to talk about the ME in Sustainable Electrical Energy Systems. Malabika.
Yeah. Thanks, Michael. Hi, I am Malabika Basu. I look after the program Sustainable Electrical Energy Systems. So it is targeted primarily towards educating professional engineers so that they can work in the power industry. And the course modules in a standard format for a full-time 1 year are divided into 5 per semester. And based on the design at present, they are fairly compulsory modules, except the option of 1 elective in the second semester. So from the title itself, perhaps the names can suggest Michael can, okay, yeah. So the first semester starts with the broad introduction about the energy industry in conventional power and the renewable sector. And along with that, some generic skills are also provided with some core compulsory modules which are common across all ME programs. So they are the research methods and the entrepreneurship for engineers. And part of the energy supply module is also dealing with the overall policy aspects. And also policy aspects, so with respect to the renewable energies. And then apart from the renewable and upcoming technologies, there are some first prerequisite modules are in power system analysis. So that helps to analyze the conventional power system so that the appreciation can be extended further. And the second semester modules are a little bit advanced. So some of the first semester modules are mandatory for that, particularly for power systems analysis 2 and embedded generation. And then 2 compulsory modules are there on statistics and innovation and knowledge management. And this semester, there is an option if somebody is more interested into the building energy systems. So they require to choose the sustainable building design. And then if it is a gas electricity market oriented power system economics oriented interest, then the elective is ideal for that kind of persons. Then the third very important module is also power electronics and energy conversion. So this is the application of power electronics in the high power industry. So that also helps in doing projects in the third semester. So the third semester is essentially a summertime semester, but the basic work starts from the first semester research methods module onwards, where the students select their project topic and start to do initial literature survey, and second semester onwards start to build up on the project, and then so that at the end of completing all the core teaching modules or the 5 ECTS based module, they can fully devote on the project module. So that's the summary. So probably
Thank you. Thank you, Malabika. The next one is the MSc in Electronic and Communications Engineering, and I might just ask Mark to speak to that one.
Okay, so good evening, everybody. My name is Mark Davis. I'm an assistant head of school in the School of Electrical and Electronic Engineering at TU Dublin, and I'm responsible for the MSc in Electronic and Communications Engineering, TU 203. This is a whole-time program of 90 ECTS credits, and it comprises 12 modules, each of 5 ECTS, and a 30 ECTS thesis dissertation. And this program is particularly aimed at graduates who basically recently completed a degree in electronic and/or communications engineering. It's primarily intended to address the requirement for level 9 engineers, that is those with a master's level, particularly in the needs, particularly in terms of the modern electronics and telecommunications industry. So for example, this might be companies, for example, might be device or chip manufacturers such as Intel. It could also be, for example, network equipment manufacturers, people like Nokia or Huawei. Or alternative could also be network operators, for example, mobile phone companies like Vodafone or Tree Mobile or companies like that. So the actual program itself is organized across 2 semesters. So the program actually runs September to September. It's a 12-month program. Semester 1 runs from September through to January. And in this particular module, you will study 3 modules of 5 ECTS credits each. And similar to the previous program, we have a 4+2 model. So there's 4 technical modules you take and 2 professional engineering modules you will take. So the engineering modules are VLSI Design 1, VLSI Design 2. This is very much concerned with how you actually go about designing modern day chips. And then also nanofabrication. This is the type of thing that Intel do. It actually involves producing the wafers that ultimately the chips are actually made from. And also then looking at some modern communication systems, those based upon optical communications, that's optical fibers, and then also around RF and microwave engineering. The 2 professional engineering modules, these are core modules that are taken across all the level 9 master's programs here in the university. And in semester 1, we deliver modules in entrepreneurship. Again, it's a very important aspect for engineering. So a lot of engineers go on to start up their own companies. So this tells you a little bit about entrepreneurship and how you'd actually go about, suppose I'm taking an idea and turning it into a company. And then also research methods. And the research methods is intended to prepare you for the research thesis that you effectively take later on in the year. Semester 2 then runs from February through to June. Again, it's a similar model to the one in semester 1. It's a 4+2, 4 technical and 2 professional modules. The technical modules are nanofabrication 2 and optoelectronics 2. These effectively carry on or continuation modules from the semester 1. And also we have a special modules then on specifically dealing with wireless communications, the type of technology that, for example, goes into the design of modern mobile phones and also as well wireless local area networks. And also then a very, very important consideration nowadays, of course, is security. So we also have a module in network security which deals with the type of techniques and encryption methods you might use to try and protect your information. Again, as well, of course, we also have the 2 core professional modules. In this case, the ones we offer are innovation knowledge management and also statistical analysis for engineers. And the sort of third big piece in all of this is the project dissertation. And as I said, this is 30 ECTS credits, so it's got a substantial piece of independent research that is carried out by the student themselves. This usually starts around late November, early December, and it runs right through to the following September. So it's quite a substantial piece and is usually examined early in September. So the program runs from September through to September over the full 12 months. The actual lectures run from September through to May, and after that then you're expected to work on the thesis dissertation over the summer months. And ultimately then you're expected to hand in the report or the thesis usually at the end of August, where it'll be assessed in September. So I'll leave it there and maybe move on to the next presentation, yeah. Michael.
Thanks, Mark. So the next presentation is the MSc in Energy Management, and like with the other ones, we have full-time and part-time. So I'm going to ask my colleague Emma Robinson to talk about this program. Thanks, Emma.
Perfect. Thanks a million, Michael. So my name is Dr. Emma Robinson, and I am the program chair for the MSc in Energy Management. And as Michael said there, we have the full-time version and the part-time version of the program. So the full-time, like with the two previous programs, runs from September to September, and then the part-time is over 2 to 3 years. So the MSc in Energy Management is really, it's our version of a cross between an engineering, so a technical master's, as well as getting the sort of the business side in. So the idea behind this program is really to look at the integration of your energy environmental issues with the business side that you face out in industry. So we developed this program and have had a very strong sort of track record of many students going through it who actually are developing into stronger managers. So you're really focusing on engineers and some scientists coming through the program who are looking to get into that technical field and the management roles in those companies. So to do that, the students cover a broad range of different subjects. So if we're, sorry, Michael. So what we're looking at is really things across your law, anything to do with technology. We go into the renewable energies, I'll go into the specific subjects there, but we also look at the field across Europe and what are the developments going on there. So if you want to get into the MSc in Energy Management, the entry requirements are a 2-2 award and an honours bachelor. So again, engineering or science, we look at each different applicant. So if you do not meet that standard, please do get in touch, and we can go through what other things that you might have done within your career up to date that might actually meet that standard. But do please reach out if you're interested in the program. It is a common entry there for the program. So when you're looking at the subjects there, our program structure has core and optional, and then the dissertation in stage 3. So we do differ a little bit from the previous two programs in that we actually have 13 taught modules and then the dissertation. So our stage 1 is the core modules, and those will be taken in year 1 of a part-time program, or they're taken in semester 1 and semester 2. So 3 in each of the different semesters in your first year on the full-time version of the program. So you can see there that there's a balance between your business and law and financial decision-making, and then your technical modules. So your energy conversion and use, energy management principles and practice, and energy supply. Stage 2 is your optional subjects, and depending on the year and the interest levels of the student body, there are several of these subjects run. Again, they are either business or technical. And in stage 2, what the requirement is that you take at least 3 technical modules and at least 2 business modules, but you can choose to do 3 and 3 or 4 and 2. So there is a bit of flexibility there. And you can see there that there's a broad range of topics, everything from wind energy for electricity supply, renewable energy technologies, power systems analysis, if that's the area that you're in, or low energy lighting and design. And then we have also the more businessy ones, so financial management. We've got energy project appraisal, which is run previously, and there's a lot of breadth in there, so that you can really tailor the specific subjects to your career development goals. And then in stage 3. Sorry, stage 1, sorry, we went through that. Apologies, Michael. So stage 2 is there. So then in stage 3, what we do is you do the project and you do your dissertation along with your research methods. So if you were taking the program full time, your research methods is taken from September or October through to about the January or February, and then you start your project. So it's 5 credits for the research methods, and then it's 25 for the dissertation, and the dissertation runs through to the September. If you're taking the program on a part-time basis, stage 1 would be your first year, stage 2 is your second, and then you would generally take research methods in stage 2 and then complete your dissertation in stage 3. We have an awful lot of students who come who are working in industry. At the moment, all of our lectures and everything are in the evening. So if you're thinking of doing the program, it is based on 3 or 4 evenings a week, full time. And so it is a full-time undertaking, but it is possible if you're working on the part-time version of the program to actually work and complete this program. So myself and Keith Sunderland are in charge of the management of the program. So if you would like to get in touch, please do. Our program is accredited by the Energy Institute, which is one of the professional bodies in the UK. And it basically means that we have a really high standard in terms of Energy Institute, but most of our other programs are accredited by Engineers Ireland. So there's a huge range of very professional elements to all of our programs here. Thanks a million for listening. And if you have any questions, please do drop us an email or pop one into the chat there.
Thanks, Emma. Thank you for that. And so the next program I want to look at is the MEng in the Internet of Things, and I'll ask Paul Stacey to speak to this one. Thanks, Paul.
Hi, good evening, everyone. So my name is Paul Stacey. I'm going to talk to you about the Masters of Engineering in Internet of Things Technologies. Okay, so first off, I mean, the aim of this Masters then is to provide highly skilled graduates to enable what we call, I suppose, the growing world of the Internet of Things. So what is the Internet of Things then? So when we talk about the Internet of Things, we're really referring to the trend towards, you know, the increased sensorization and instrumentation of all the world around us. So that's really where we deploy technologies to enable the collection of data and information about, you know, a lot of the things around us, but specifically, I suppose, in the environment, around the society and industrial processes, with the main aim that we can make them better, or we can understand them better, and then more efficiently manage them, I guess. So this is increasingly important as the world attempts to deal with, you know, increasing pressures and constraints on what is very much a finite set of resources that we all have, and then consequently the need to better manage them through use of and deployment of smart technologies. So to realize then the true potential of what we call the Internet of Things, we need highly skilled graduates then who are expert not just in, you know, electronics and embedded systems, but also are very conversant and skilled in software development, statistical machine learning techniques, networking, data and information management, and analytics then. So a really broad range of technologies. So next slide there, Michael. Okay, so the emphasis of the program then is really on applied skills. So with the modules that are listed there, designed, many of them in collaboration with industry. So they're, you know, they really are meeting the perceived needs of graduates in industry. So a core element then of the Masters, like the other programs here, is the research project. And the Masters then is offered in both part-time mode and full-time mode. The part-time offering is commencing this September 2022, but the full-time offering won't commence until September 2023. So the part-time offering is available for applications now, and the full-time offering will open for applications this coming October. What's maybe unique about this program is that within either mode, so full-time or part-time, there are actually 2 pathways, so 2 ways to complete the actual program. So when you apply and when you are successful and register, all students, be they full-time or part-time, will register on what we call Pathway 1. So Pathway 1 is a more traditional approach to the Masters. So it consists of your 60 credits of taught modules and then a 30 credits project. And Pathway 2 then consists of 30 credits of thought with actually 60 credits of a more in-depth research-based project. So all students register in Pathway 1 initially, which is the TU 202 OR code, and then based on a research plan and a research idea that you develop as part of our research methods module, you may apply and may be accepted onto Pathway 2, but this is very much in exceptional circumstances, whereas most students will complete in the more traditional pathway. So the program in full-time mode is developed over 3 semesters, so September to September, and then part-time mode is 6 semesters over a 2-year period then. So the program will be delivered in hybrid applied format, so with a mix of online and on-site. The on-site is certainly important in terms of the applied nature of the program. So we have practical learning sessions, and what they do is combine the theory based learning that you will do in a certainly a hybrid approach, while working through industry relevant and practical assignments. So this gives you the opportunity then to interact with other students on very kind of industry relevant problems. So slide 4 then, Michael. So to gain entry to the course, so first of all, the course is really aimed at individuals who are interested in becoming skilled in a broad range of technologies, rather than, I suppose, in a very specific, singular, I suppose, discipline area. So, which is what the Internet of Things really needs in terms of industry skills and so on. So it's ideal then for both recent graduates in the cognitive disciplines that are mentioned there. So computer science, computer engineering, electronic engineering, and more besides then. And also, I suppose it's very much open and of interest to people who are working in industry, especially in the part-time format, who may want to gain additional skills to support IoT efforts, either in their own company or indeed client organizations that they may be dealing with. Okay, thank you very much.
Thanks, Paul. And the last presentation is from James Wright, and it's on TU 212, the ME in Electronic Design Engineering. Thanks, James.
Thank you, Michael. Hello, my name is James Wright, and I'm just going to talk to you about the Master's of Engineering in Electronic System Design that we deliver. So this is it really. Master's is very much focused on hardware, high-speed hardware design, high-speed hardware digital design, with an element of analog as well. So this would be aimed at modern high-technology industries, employers such as Xilinx, Intel, Microsem, Analog Devices, Synopsys. These are companies that all work around the design of circuits within FPGA devices, or actually in custom chip design. And so this program really focuses on the actual hardware logic design of these devices. So what we need to for entry for this program would be a BA and Jones in electronics or a cognitive similar area, and you need a 2.2 honours degree. But also people with experience in the area or working in the area also can come and inquire as to entry to the program. So we can turn the page now. We can actually look at the components of the program. If you flick over there, Michael, thank you very much. So basically, there's 8 modules which are to make up to 60 credits, and then you have a project at 30 credits. So it's a 90 credit program, and at the moment we will be offering this program in September as a part-time delivery, and we would eventually then include it in our full-time program. But this September we'll be looking at providing a part-time program particularly for those already employed in the industry who wish to upskill. As a part-time program, it takes 2 years part-time, and we would deliver it over 2 evenings a week. So that would be 2 3-hour slots, one on a Tuesday, one on a Thursday is the current plan. So if we look at the components and the structure of the program, really it has 4 teams. 4 or 5 teams. So for instance, there's a digital design team, and that would have 4 modules contained across the 2 semesters. So it would be digital design. There's 2 modules in high-speed digital design. There's a modeling and synthesis module, and there's the digital verification module. So that would be 4 modules, all concentrated in the area of digital design. And then the high frequency design module is focused on analog. So it's the actual analog blocks that you'd come across in these devices, be it a custom chip or an FPGA. You have a certain in mixed design scenarios, you would have a certain element of analog. So in that case, in the high frequency design, we'd look at analog and high speed analog design there. And then there is a software stream as well. So that would have an engineering software module, which is about upskilling people on the relevant object-oriented type skills for engineers, particularly working in the areas of vision and DSP. And also we offer an elective in software design. So your last module, the 8th module, you choose an elective between software design and RF. So you could take two software modules as well. Then we have this other module which is our RF, and that's around digital circuit design and wireless systems at the physical layer. So you would design amplifiers, RF amplifiers, which will be designed on a chip. The project then, oh sorry, I should mention as well that there's a research methods module which is connected directly with the project, and that will you'd look at doing all the methodologies around studying literature searches, how to do independent research, and all that was needed to write a major project, a major dissertation, and that would be done alongside you when you start thinking about your dissertation itself. So the project dissertation would be in the area of device design, FPGA design, or chip design, and including all the skills of digital and analog and RF systems. Now, if you're working in industry, you also can include a project that you may be involved in an industry, as long as you can locate that project as your own, that the work that you've done. So really, this is what we do here is try to cater to the companies that work in high-speed digital, high-speed design of chips, high-speed design of FPGAs, and of which there's many. And we've ran this program several times now, and it's quite successful. What we can do as well is the earlier modules, the digital system design and the modeling design, we will often offer as CPD. So you can take a module and take it as a single subject certification if you just want to take that module rather than complete the program itself. But then the program as well, if you don't take the project, you can take it as a postgraduate diploma and so on. So really it's very flexible for those working in the industry, and it provides very valuable skills which are very, very sought after in the industry also. Okay, Michael, that's it.
Thank you very much. You, James.
Thank you.
Okay, thanks to all the presenters for that, and I'm just wondering if there are any questions we can take. No problem.
I just saw a general query about the timing, and I think Keith and Emma has replied it. But if you like to just mention the general timing, that might be recorded also for convenience.
Yeah, so this is in terms of full-time and part-time, yeah? Yeah,
and also the evening class timings and schedules.
Yeah, so you know, to a lot of the modules will be presented in the evenings, and it's possible to put together a program, you know, an arrangement that is going to allow you to complete in part-time mode. And I suppose really the important point I'd make is to contact the program coordinators who'll be able to give you information. I know making a decision like this can be a significant task, but you know, if you want to contact us over the coming weeks, we'll be able to fill you in on how things are progressing, and you know, how your application is proceeding. Yeah, so I'm not sure if anyone has any questions that they want to put to us at this stage, but or if they'd like to type them in.
I would also like to raise another point, Michael, for international full-time students. I think they need to apply early enough, and typically our application deadlines are end of April, though I think it's not yet put up in the website, but I got some queries, so I just thought of putting this into the recordings.
Yeah, that's a good point. Yeah, just to factor in that that visa application stage, and you know, the university works hard on this to facilitate it, but just it makes it easier for them if the applications are in and they can focus on individual applications then.
And for part-timers, Michael, is it mandatory to be currently working, or anybody who is legitimate to stay in Ireland are able to join?
Sorry, just say it again, Malabika.
For the part-time modules or part-time courses, is it mandatory to be working somewhere in industry?
For part-time, this would be for students outside of the country, is it?
No, no, for students
No,
residing,
no,
but no, it's
no,
not mandatory.
no, not at all. No.
Yeah.
I see a question there from Kieran looking at the part-time course in sustainable electrical systems. And the question is, can lectures be online or are they on campus? Yeah, Keith has responded there about a blended approach. Look, we've been very much moving from 100% online back into, I suppose, a hybrid mode of presentation. So my own modules in that program, they have been online because we would have started last September when everything was online. I think most colleagues are developing the ability now to deliver both online and in person, and certainly we have the facilities to do that. So we are very adaptable in that regard. So it depends how things are going next year. But I would certainly, for myself, I would plan to have in person, but also have them recorded, or be able to participate online. And then for me to be fairly flexible about meeting people, any tutorial elements to facilitate that. But look, we're all sort of moving to a different mode of delivery when it comes to all programs, but I think master's programs are probably the most flexible for us to do, and there's probably also where the greatest demand is to have that hybrid mode of delivery. So look, we're very open to working out something that will work. We've said in the past, with COVID and so on, that we're going to do something by next September, but I think we've all learned that we need to be very, very flexible in regard to this. First of all, thank you for attending this evening, and thank all my colleagues for participating, and good luck for the rest of the evening. Okay, thank you.
Thank you.
Thank you very much.
Thanks.
Thanks, everyone. Bye.
Thank you. Bye-bye.